Our ocean of air, an introduction to the atmosphere, meteorology. It's the science of the atmosphere, this vast, invisible ocean above us. It dictates our weather, our climate, our very lives depend on it. Understanding this ocean is not just a task, it is a profound human endeavor, a journey into the forces shaping our world. The atmosphere is a restless place, always churning, always changing, a tiny flutter of a butterfly's wings. Could it truly start a hurricane? Perhaps not so directly, but the principle holds. Small events can ripple outwards, creating large, complex weather patterns. This is the dynamic beauty of our sky. To understand this complexity, we observe, we measure, we collect data. Satellites gaze down from orbit, weather balloons ascend to the heavens, ground stations dot the Earth's surface, each instrument a silent witness gathering clues about the air's secrets. These tools extend our senses, allowing us to perceive the imperceptible. These measurements describe key parameters, the fundamental properties of the air. Think of them as the notes in a grand symphony, each one distinct, each one vital. Together, they compose the music of the weather. Temperature, pressure, humidity, wind. These are the characters in our atmospheric story. Let us explore them. The invisible dance: temperature, pressure, and Earth's moisture. Temperature, it is a measure of molecular motion. How fast are the air's tiny particles jiggling? Faster means warmer, slower means cooler. This simple idea has vast consequences. Warm air rises, cold air sinks. This dance drives winds and storms. Farmers rely on temperature for crops. Our comfort, our energy use, all tied to it. Temperature shapes ecosystems across the globe. Atmospheric pressure. Imagine a column of air stretching from your head to space. That column has weight. This weight presses down. That is pressure. High pressure often brings calm, clear skies. Low pressure can mean clouds, rain, or storms. Pilots use it to know their altitude. Weather maps show these highs and lows, guiding forecasts. Humidity. The air holds water unseen. As a gas, called water vapor, humidity tells us how much is present. The mixing ratio is more precise. It's the mass of water vapor compared to the mass of dry air, a specific quantity. This helps scientists track moisture content accurately, essential for understanding cloud potential. Then there's the saturation mixing ratio. Air cannot hold infinite water vapor. There's a limit. This limit depends on temperature. Warmer air can hold more moisture. When air reaches this limit, it's saturated. If more water vapor is added or air cools, condensation happens, clouds form. This is how rain, snow, and fog begin their journey. Flows of energy and air radiation, wind and vertical journeys. Radiation, the sun, our star, it bathes Earth in energy. This energy arrives as shortwave radiation, light and heat. Earth absorbs some, reflects some. Then, Earth radiates its own energy as long-wave infrared radiation back to space. This balances Earth's energy budget. It drives our climate, our seasons, and powers life. Solar panels capture a tiny fraction of this cosmic gift. Wind velocity, air in motion. That's wind. It's caused by differences in pressure. Air flows from high pressure to low pressure, trying to even things out. Wind has speed. It has direction. We measure both carefully. Sailors have navigated by it for millennia. It powers wind turbines, generating clean energy, and it steers storms, sometimes with devastating force. The adiabatic lapse rate. Imagine a parcel of air rising. As it rises, pressure around it decreases. The parcel expands. This expansion uses energy, so the parcel cools without any heat exchange with its surroundings. This cooling rate is the adiabatic lapse rate. There's a dry rate and a moist rate for cloudy air. This concept is key to cloud formation and understanding why air rises or sinks. The environmental lapse rate. This is different. It's the actual temperature change with height in the atmosphere around that parcel, at a specific time and place. We measure it with weather balloons. By comparing it to the adiabatic rates, we can determine if the atmosphere is stable or unstable, ready to brew thunderstorms. This knowledge helps predict severe weather and air pollution spread. Charting the winds and understanding the whole picture. Wind roses, a beautiful name for a useful tool. It's a graph, a diagram. It shows wind patterns at a location. How often does wind blow from the north? How strong is it typically? A wind rose answers these questions visually. Engineers use them to design airport runways, to place wind turbines for maximum energy. Architects use them to plan building ventilation. A simple chart, revealing complex local wind climates. No single parameter tells the whole story. Temperature affects pressure. Pressure differences create wind. Wind moves moisture. Radiation drives it all. Lapse rates determine stability. Precipitation is the result of these interactions. They are all connected, intertwined, a delicate, powerful, cosmic ballet. Understanding one helps understand them all. For students of meteorology, for professionals, these parameters are your language, your tools. You use them to forecast the weather, to protect lives and property, to research climate change, to understand our planet's intricate systems. Each number, each measurement holds a piece of the puzzle, a puzzle that describes our world. The challenge is to see the bigger picture they paint. Our quest to understand the atmosphere continues. It's a journey of constant learning, of discovery. From the smallest water droplet to the largest hurricane, these parameters guide us. They help us read the sky, to comprehend the forces that shape our daily existence. The universe is in every gust of wind, every drop of rain. Look up, wonder, and understand.